Hello students, we'll continue with the topic dyes. In the last session we had discussed about the definition of dyes, then the classification of dyes based on the structure and application. In this session we'll be discussing about the color and constitution theory. Okay, now and then if possible we'll be discussing preparation of some of the dyes. Now let us see first why substances appear color to our eyes. All the substances absorb some portion of sunlight and reflect the remaining portion. Okay, when a light falls on a substance, small portion of the light will be absorbed and the remaining will be reflected back. The reflected light falls on the retina of our eyes and we sense the color. The color of the reflected light is the color of the substance. So the color that appears to our eyes is the light that is reflected by the substance. It's not the light that is absorbed by the substance. If a substance absorbs UV light, then it appears colorless to us because we cannot sense the UV light that is reflected. Our eyes can only sense only the visible portion, that is the light that falls between 400 to 700 nanometers. If the substance absorbs visible light, then only it looks color to our eyes. For example, if a substance absorbs blue light, then it will reflect yellow light. It is when white light falls on an object, if it absorbs blue, then the reflected light will appear yellow to our eyes. If it absorbs yellow, then the substance will appear blue to our eyes. Therefore, blue and yellow are referred as complementary colors. So if a substance absorbs blue, it appears yellow, and if it absorbs yellow, it appears blue. Okay. So this is why the substances are generally colored in nature. Why generally dyes are colored? Okay. This can be explained based on a theory which is called as a chromophore auxochrome theory. Chromophore auxochrome theory. Okay, a German chemist, Otto Witt gave this theory, hence the we even call it as Otto-Witt theory also. The German scientist was the first to explain the theory of color and constitution. According to this theory, a colored substance or a dye is essentially composed of two parts. According to this theory, a colored substance is composed of two parts. One is chromophore. A color substance contains two parts. One is chromophore, other one is auxochrome. These are the two parts a colored substance actually possesses. Let us see first what are these chromophores. Chromophores are multiple bonded functional groups which are responsible for color. So the color of a substance is due to certain multiple bonded functional groups. Color of the substance is due to the sum of the multiple bonded functional group. Those are referred as chromophores. The chromophores are the color bearing groups and their more presence produces a color in the molecule. That is, the presence of certain functional group imparts color to that. The color of any dye depends upon certain functional groups and those functional groups are referred as chromophores. If those functional groups are not there, then that substance will be colorless. So example of some of the chromophores are nitroso group are chromophores. NO2 nitro group is a chromophore. Diazo group is a chromophore. Okay, even quinoid ring, paraquinoid, quinoid is also a chromophore. Even carbonyl group is a chromophore, carbonyl. So these are chromophores. But the presence of these groups, uh, due to these groups present in a molecule, that molecule will have a color. So those are called as chromophores. So the organic compounds containing a chromophoric group is referred as a chromogen. Okay, now let us see what is an auxochrome. See, auxochrome are certain groups which are not responsible for color, because presence of this group will not be responsible for a color. That means if a dye is colored, it will not be due to the chromophore. But the presence of these groups along with the chromophores will intensify the color. The presence of these groups will intensify the color. Okay, for example, so if there is a diazo compound, that is yellow in color, I mean a deep yellow color. If you introduce a auxochrome to this, so the color will become more deeper. That means it becomes a reddish yellow color. Okay, so auxochromes are the groups which do not produce any color, but presence of these groups will intensify the color. So these are called as chromophore. So these are the functional groups whose presence will result in a color of a substance, and these presence will intensify the color. That means if auxochrome is present alone, the compound will not be colored. If the auxochrome is present along with the chromophore, then only the compound will be colored. Okay, now carbon-carbon bond is not a color, not a chromophore, where nitrogen-nitrogen double bond N is a chromophore. Presence of a chromophore is not just sufficient to give color. There is another requirement. The requirement is chromophore must be attached to a conjugated system, conjugated double bond. I will give an example. See, we all know that NO2 group is a chromophore. Right? Nitromethane, that is CH3NO2, is colorless. That means mere presence of NO2 group will not impart color. This nitrobenzene, NO2 group is linked to a conjugated system. So this is pale yellow in color. Okay, presence of only NO2 group will not impart color. That means the chromophore should be linked to a conjugated system, then only it will be color. Okay, now another thing is, the greater the number of chromophores in a chromogen, the greater will be intensity of the color. As the number of chromophore increases, the color goes on increasing. I mean the intensity of the color increases. Okay, now the presence of auxochrome makes a chromogene. What is a chromogene? Chromogene is nothing but an organic compound containing a chromophoric group. Makes a chromogene a dye. Okay, so this is about the auxochrome chromophore theory that was given by Otto Witt, which says that a dye consists of two parts. One is chromophore and the one is auxochrome. Chromophores are certain functional groups whose presence will be responsible for a color, and auxochrome, if they are present along with the chromophore, they generally intensify the color. To sum up, the colors of an organic compound according to Witt's theory are explained in the types of position of the chromophores and the auxochrome present in a molecule. The greater the number of chromophores, the longer the conjugated system, deeper will be the color. That means as the number of chromophores increases, And as the systems become more conjugated, conjugated means if there is alternate double and single bond, look at this, it is colorless, it is colored. So as the conjugated conjugation increases, the color goes on deep. We do come across another two terminologies here. One is bathochromic shift and other one is hypsochromic shift. Bathochromic effect or an hypsochromic effect. Let us see what is this bathochromic effect and an hypsochromic effect. See, introduction of oxochromes like NH2, OH in a chromogen shifts the absorption band from lower to higher wavelength, that is from violet to red. Okay, so you know Vibgyor, so violet to red, there will be shifting of color will take place due to the presence of introduction of NH2 groups and OH groups. The oxochrome deepens the color by extending the conjugated system between the chromophores and the oxochromes. Okay. What is this bathochromic shift and the hypsochromic shift? Introduction of oxochromes like NH2 and OH group in a chromogen. You know what is a chromogen? Chromogen is an organic compound containing a chromophore. Shifts the absorption band from lower to higher wavelength. This shift is called as a bathochromic shift. Okay, or the effect is called as a bathochromic effect. Even you can call it as a red effect or a red shift. Red shift is what we call it as, or you can call it as a bathochromic shift or a bathochromic effect. There are certain groups which bring about the opposite effect and shift the color. So there are certain groups which bring about the opposite effect and shift the absorption band from red to blue. Red to blue. That is from higher wavelength to lower wavelength. This shift is called as an hypsochromic shift or a blue shift. Okay. It may be concluded that the bathochromic shift is the shifting of the absorption band from longer wavelength shift band to longer wavelength, whereas hypsochromic shift is a shift of absorption band to shorter wavelength. Okay, so this is the color constitution and about the Auto-Witt theory. Now let us discuss the preparation of few dyes. Okay, for a syllabus we have synthesis of few dyes. One of the most important dye that we are going to discuss is an azo dye. You know what are these azo dyes? These dyes are characterized by an aromatic ring system linked to an azo group. Azo means nitrogen. Diazo group is what you can N double bond N group. This N double bond N group is the chromophore. That is, color of the dye is due to the presence of this group only. So when I say azo dyes, these are the dyes which contains diazo as the chromophore. To deepen the color of the azo dyes, oxochromes like NH2, there may be oxochrome like NH2, OH, SO3H may be present. So one of the important example of this azo dye is Congo dye. So today in this session we'll be discussing the synthesis of this Congo dye. Congo dye is an azo dye, diazo dye, as it contains an diazo group. Okay. It is prepared by coupling tetraazotized benzidine. What is this azotized means? if we have an aniline, if aniline is treated with HNO2, HNO2 is nitrous acid, so the NH2 group gets converted into N2 plus Cl minus. This is called as a diazotization. Diazo, that means two nitrogens are there. This process is referred as diazotization, and the compound is called as diazonium salt is what is called. So similarly, tetraazotized benzidine, okay, when it is treated with naphthenic acid, you get the Congo red dye. Okay, let us discuss the synthesis of the Congo dye. Let us discuss the synthesis of Congo red dye. Now, tetraazotized. See, this is diazotized. Diazot. So tetraazotized benzidine is taken. Right? N, triple bond N plus Cl minus, N, triple bond N, Cl minus. Okay, this is tetraazotized. See, diazotized 1, 2, 3, 4 nitrogen. So this is called as a tetraazotized benzidine. Right? This when treated with naphthenic acid. I will tell you naphthenic acid. What is this naphthenic acid? This is naphthalene, you know this. NH2SO3H. This is naphthenic acid. This is naphthenic acid. When this molecule is treated with naphthenic acid, two molecules of naphthenic acid gets coupled. Coupled, that means they just combine. Results in the formation of a compound that is Congo red dye. You carry out the coupling reaction. Coupling. They couple out. So what happens is, this nitrogen gets attached to here, this position. The position adjacent to NH2 group here. NH2 here. Similarly, another nitrogen, this will attack this position of another molecule. So there are two molecules here. Okay, I will just write the structures so that you will have an idea. We have two benzene rings. Okay, we have nitrogen compounds here. Then this molecule, I will just write this molecule so that we will get a clear picture about this. I have written the other way around. NH2SO3H. NH2SO3H. So two naphthenic molecule and this compound, that is N. This nitrogen will attack here, this position. That means the nitrogen, there are two nitrogens, it will attack this position. So triple bond will get converted into a double bond. So you have N double bond N, the nitrogen attacking here. N double bond N and the nitrogen attacking here. Okay, this is called Congo red. So Congo red is just prepared by coupling reaction, that is tetraazotized benzidine with naphthenic acid. Okay, this is Congo red dye. if you treat this with NaCl, you get disodium salt. When you treat this with NaCl, this H gets replaced by Na plus. So you get SO3 minus Na plus and SO3 minus Na plus. That is called as disodium salt is what we call it as. So Congo red is used for dyeing cellulose fiber. Okay. It is an important acid base indicator. It is red in basic medium. Congo red is red in basic medium. So Congo red dye is red color in basic medium. Okay, and it is blue in acidic medium. And it is blue in acidic medium. Okay, it is red in basic solution and blue in acidic solution. The change in color from red to blue in acidic solution is due to the certain structural changes that occur. So you should know the preparation of this dye, that is the Congo red dye. When you treat this with NaCl, this H plus gets replaced by Na plus. So that is called as disodium salt. So it is an best example for an azo dye. Right? Hope you got an idea regarding this. Right? So this was regarding the preparation of the azo dye. This was the preparation of azo dye. So in this session, what we have done is, so far we have discussed the color and constitution, and then we have discussed the synthesis of azo dye. In the next session, we will discuss the synthesis of the remaining dyes.